right, we're going to look at this example that's on your classwork. This is called city mileage, highway mileage. We expect a car's highway gas mileage to be related to its city mileage in miles per gallon. Data for 1,137 vehicles in the government's 2013 fuel economy guide give the following regression line. So they're saying the highway miles per gallon is equal to 6.785 plus 1.033 times the city miles per gallon. So this is really your y here. And this would be your x. And the number being multiplied by the x is your m. That's your slope. And then the number by itself is your intercept, b. All right, so I would like you to pause the video and try and get through A through G. And if you can, if you think you can do these predictions, go ahead and give those a try. And then we'll go through them together. All right, so hopefully you gave that a try. My explanatory variable here, this is my x and my response is my y. So that would put city miles per gallon if I was drawing a little picture. So there's my city, would be down here on the x-axis, and my highway is going to be on this vertical or y-axis. Okay. So we'll fill this guy in. Right, then the slope of the line, so that's the number being multiplied here by my independent variable, is 1.033. And my intercept is 6.785. All right, so my interpretation of the slope, so that's going to be as x increases by 1, y increases by the slope amount. So when my city miles per gallon increases by 1, my highway miles per gallon, and then I'm going to choose the word increases because this was positive. If this was negative, I would say decreases, but I'll say increases because it's positive. And it increases by 1.033 miles per gallon. So there's my slope interpretation. And then for my intercept, this one is when x is 0, y is this value. So when my city miles per gallon is 0, okay, my highway miles per gallon will get 6.785. All right, so the value of the intercept is not statistically meaningful, and that's because I don't know if any car that doesn't drive in the city, right, essentially getting 0 miles per gallon. I mean, you can't drive in the city, but somehow you can magically drive on the highway. So I'm gonna put, don't know a car like that, because I don't. I don't think that that's possible, but maybe. And then as far as these predictions, so to get a prediction, all I need to do is plug this number in for my independent variable. So y here is going to be 6.785 plus 1.033 times 16. Let's put that in my trusty calculator and see what I get. So it looks like I get about 23 miles per gallon. And then it asks me to do the same thing, but if I'm getting 28 miles per gallon in the city. So it is the exact same formula, but I'm just going to replace the 16 with a 28. And so that's going to give me about 35.7 miles per gallon here. All right. So that's an example just using an equation that's given to you. And now let's take a look. We're going to revisit that manatee problem we looked at earlier, and we're going to look at how to add that regression line to our scatter plot. So let's switch over to Excel. All right, so here's our manatee scatter plot from earlier. Remember that this is related to the number of boats and then the number of manatees that die, unfortunately. So we talked about this having a positive relationship, and that is the number of boats increase, the number of manatees that die also increases. But let's go ahead and add a regression line to this. So if I double click on this guy, I get my design menu back up here. So that's what I'm looking for. And I'm going to go to add a chart element. We've played around with some of these things before. We've played around with axis titles and data labels and things like that. We're going to go all the way down to trend line. And what you want to do is choose the more trend line options. So you want to actually get this whole panel to open up. And if it doesn't open up correctly, the best trick is actually just to close the side panel and try and reopen it again, and it should open to the right spot. So you're looking at this one that gives you some choices about what type of trend line. We're going to do linear in this class. If you took a more sophisticated stats class, like maybe a 400 level or a graduate level, then you could start looking at maybe some of these more advanced techniques. So I have my line, so put that line on there. And then if I look at the bottom of this panel, this is why I wanted to pull this up. I can click this button that says display the equation on the chart. There's actually another button there that we're going to eventually use as well. Put the r squared value on there, which seems like I've lost mine for the moment, so that's okay. So here's my equation. Y is equal to 0.1323x minus 44831. So I'm going to write that down on my classwork. So y is equal to 0.1323x minus 44.831. Okay, if you want to see that one more time, the way I did that, I'm going to close this panel. I'll get rid of this equation. I go to add a chart element, down to trend line, more options. And I'll click the display the equation, and then this r squared one I'm going to put on here too. We're going to talk about r squared in a later video. Right, but there's that process again. Okay, and then this will allow us to finish this up. So interpret the slope in context. So my slope value is 0.1323. So I would say something like, as the boats increase by 1, manatee deaths increase by 0.1323. And then my intercept there is a negative 44.831. And so I get when the number of boats is 0, the number of manatees that die is negative 44.831. Now that doesn't sound very realistic to me. So I would say that this is not statistically meaningful, the interpretation of the intercept. Okay, and then our last part here is it asks for the r squared value. So we're going to write that down, and then we're going to come back and revisit the rest of that question. But since we're here, we'll write down that r squared is 0.9091. So there are a number of ways you can get that. One is getting it from the graph itself once you put that equation on there, that line on there. The other is to actually just take your r value and multiply it by itself. So essentially squaring it, right? And that will also give you that same exact number. So there's two different ways to do that. All right, we're going to take a look at one other example. This is the murder and homicide rate that we looked at earlier. And I want to add those regression lines to this one because I want to show you what that looks like in Excel. So if I click on this guy to get my design menu back up, and I'll go to add a chart element. Let me get rid of this guy first. So go to add a chart element, go down to trend line. I'll do that more trend line options, and it's going to ask me which one do I want to do. So it doesn't matter because I'm going to do both of them. So I'll say OK to the caution yes group, and I'll have it display my equation and my r squared value. Okay, so that's my blue group here. So let me put their equation up here where we can see it a little more easily. And then I'm going to go back and add the line for my orange group. That's the caution no. So go back to add a chart element, back to trend line, down to the options, and I'll choose no this time instead of the yes. And then I'll And let's see, I'll do display equation and r squared value. So there are those guys. I'll just stick them up here in the right corner. So there's the equation for my R, or for my orange values, and there's the equation for my blue. So it's the same exact process. You just need to go through it twice if you're going to do this. In fact, you can expand this to more than 2 colors if you want. It starts to get a little chaotic, but you certainly could do more options if you wanted. So hopefully that gives you some help in finding those equations so that you can work on interpreting them and everything else that goes with that.